This is a lever-type nail clipper, or simply known as the nail clipper. Every neighborhood has this small tool, and everybody knows what it's used for, and how to use it. But have you ever wondered how this simple tool works so efficiently? Today, let's explore the genius behind the lever-type nail clipper, from its design and to the hidden mechanism. A lever-type nail clipper is a common personal grooming tool, used to trim fingernails and toenails. It uses a lever mechanism to apply pressure on the cutting blades, making it easy to cut nails with a small amount of force. Here's a breakdown of its main parts and how it works. Here, we have the base frame, the lever, the nail file, the pin, and the shaft. Now let's start with the base frame. The base frame comprises two main parts: the upper clipper arm and the lower clipper arm. The upper clipper arm can move up and down due to the force coming from the lever when you press it. This is also the movement that clips your nails between the two sharp blades and cuts them cleanly. At the top of the upper clipper arm, you'll see a rectangular groove on it. This groove helps the proper placement and stabilizes the lever fulcrum, so that it will not slide left or right every time you press the lever. The lower clipper arm is stationary, it doesn't move up or down like the upper clipper arm does. Its main purpose is to provide flexibility strength to the upper clipper arm, cutting support with its own blade, and to double the structural durability. These two arms combine face to each other and become the main body that houses the upper blade and the lower blade. Each has one hole for the pin placement, and often includes a small hole at the end for a keychain or chain attachment. Note that some of the lever-type nail clippers' design has a solid base frame. That makes them more durable and heavier. And for this lever-type nail clipper, the two arms are fixed permanently, mostly welded together from manufacture, and you should not separate them with force when you're planning to disassemble its part. It may break one of the arms and will no longer be usable. Next is the lever, or handle. The top part you press down acts as a lever to multiply the force applied by your fingers. It's usually mounted on a pin and can rotate to lie flat when not in use. The lumped up here is called an upset portion, the one that positions itself on the groove at the top of upper clipper arm. Next is the pin, sometimes called rivet or pivot. The pin is a small, usually a cylindrical, and solid steel rivet shaped like a hook, and lock the lever and body together. It acts as a pivot for the lever, allowing downward pressure to be transferred to the cutting blades. It also allows the lever to rotate 360 degrees, and the blades to open and close. And last is the nail file, or the filing surface. This part is optional, but some nail clippers have a small metal nail file attached underneath the lever. It is placed beside the keychain hole at the rear end of the base and locked it using the hollow cylindrical shaft with punches at the both end during the manufacturing process. It can also rotate 360 degrees for your preference, and used it to smooth the edges of nails after clipping. So, we all know now, that when we press down on the lever, it pivots on the pin, pushing the upper cutting blade down towards the lower blade. The two blades meet and cut through the nail cleanly. Releasing the lever resets the blades for the next cut. But how does it exactly work and the science behind it? Well, nail clippers primarily utilize a lever mechanism to cut nails. A lever mechanism is a simple machine that uses a rigid bar, or lever pivoting around a fixed point or the fulcrum, to amplify force, allowing a smaller input force to produce a larger output force. Levers are categorized into three classes based on the position of the effort, load, and fulcrum. The first class lever, the second class lever, and third class lever. In first class lever, fulcrum is located between the effort and the resistance. The effort is applied on one side of the fulcrum and the resistance, or load, on the other side. For example, a seesaw, a crowbar, a pair of scissors, a balance scale, a pair of pliers, and a claw hammer. With the fulcrum in the middle, the lever's mechanical advantage may be greater than, less than, or even equal to 1. Second class lever, resistance or load is located between the effort and the fulcrum. The effort is applied on one side of the resistance, and the fulcrum is located on the other side. For example, a wheelbarrow, a nutcracker, a bottle opener, a wrench, and the brake pedal of a car. Since the load arm is smaller than the effort arm, the lever's mechanical advantage is always greater than 1. It is also called a force multiplier lever. Third class lever, effort is located between the resistance and the fulcrum. The resistance or load is applied on one side of the effort and the fulcrum is located on the other side. The example tools for this type of lever are a hoe, a pair of tweezers, a pair of tongs, a fishing rod, and the mandible of a human skull. Since the effort arm is smaller than the load arm, the lever's mechanical advantage is always less than 1. It is also called a speed multiplier lever. And going back to our nail clipping tool, can you guess which class of lever mechanism it's using? First, we need to observe that the nail clipper actually consists of two moving components during cutting nails. Let's observe the location of effort, resistance, and fulcrum in the upper component. Hence, because resistance is in the middle, this upper part component of nail clipper is a class 2 lever. How about the lower component? Since effort is in the middle, then this lower component of nail clipper is a class 3 lever. And that concluded, the nail clipper is the combination of class 2 and third class lever. Now we know. It may look simple, but this little tool is a masterpiece of design. Such an incredible mechanism, isn't it? Now you know what's really going on every time you trim your nails. Thank you for watching my video.